Hi. Yes, let's continue. Sorry, I probably didn't even have to turn off for that, but that is what it is. Alright, I probably should monitor this. Sorry, I probably should have done this before turning the thing back on, but there is that. Okay, so let's see. This is fine. That is fine. Oh, sure, yeah. Where am I? Oh, I guess I'm monitoring on both sides. It's fine. I just need one of these. Well, I close this and I keep this one, I guess. Right. Okay, so let's continue where we left off. Okay. So we filled in both of the proofs here. So just close this. One file done, three to go, I suppose, or four to go, I think. Wait, the ones we did was P state, right? No? Wait, which one do we do? We did the what's going on here? Oh wait, huh? I feel so disoriented. Yeah, I feel so disoriented. What's going on here? Okay, now this makes slightly more sense. Okay, so unitary basic is done. And then what? And then Pauli unitary Pauli is a There's nothing in. Is this unitary Pauli? I guess so. And are we saying there's not much here? Unitary poly, I guess. Okay, so there's definitely this that could be done. Um, one thing at a time, I guess. Maybe do the bitVec thing first since it's the easiest. I mean, we probably should hopefully get all of it done today anyway, so there's that. Okay. So let me see here. Um, what's going on? There's really something. There's something about this sum that I could be proving. Um, yeah. So what is this? Finset sum. Um, yeah. There's probably quite a lot of can stay here. Is there a way to? Can I literally unfold this? I cannot, right? Mm, oh, maybe this. Mm, there has to be some trivial things I can do. Let's just immediately unfolds this. Maybe what's is this what I want? Um, multi-set map. So I want to say this is this, but then s dot val was s is a fin set. So s dot val would be underlying multi-set. But then what do I know of this multi-set? Well, I mean worth a try, right? What do I have to lose? Oh, okay, that is unexpected. Okay, so what do we have? Wait, my ears is itchy. Okay, this is not giving me much, is it? Um, oh, maybe it is. It's not, is it? Is this back to a multi? Yeah, this is. Okay, that is not so productive here. Um, Is there a way to just enumerate the? I mean, there has to be a way to enumerate the thing. So let's see. There has to be a way to manually provide a mapping. Except this is the huh, filter some what is this? I mean, can I literally just unfold? So what is this? This is finset sum. I mean, no, like this is, well, this is finset.sum. So what is finset.sum? Finset.sum is finset.unif. Okay, so what is finset.unif? I mean, this might or may not give me anything useful. Universal finite set. Maybe this works. Finset sum bit. What is it? Bitvec. I mean, I don't know if this works the way I think it does. Maybe it doesn't. Finset bitvec maybe. Let me see here. There has to be something that makes this free. I just don't know what is it that makes it free. I don't know. Fine. Maybe finset.sum. See what do we have here. Op sum. Is this giving me anything useful here? It is not, right? No, it's not. Mem sum maybe. Some card. Okay. Oh, that's not it. If this is in, what on earth is this? This is most definitely not what we want. That is not what we want either. What is this? Oh, maybe. What is this? Fin setup Mac. And what is this? Fin setup sum. What is this? Multi-set map. Is this? What is it? Is this? Okay, so this is, well, multi-set map. This thing. Okay. So, I mean, it's like going a bit crazy here, but how about this? Is this okay? This is giving me something meaningful here, and then if I simplify this, get nothing. Okay. So, this is finset unival. okay, this is certainly not how I want to go about it. I want to maybe, okay, let's try a different route. Let's attempt to pull the, what is it called? Let's try to, well, I mean, if there are only two terms, then I can literally just pull both terms out, and then I would be able to say the rest is empty. So how do I pull a single term out of a sum? Um, Let me see. There has to be, there has to be some kind of like sum if kind of thing, right? Since some like if. Well, there's this as well, but this is maybe, you know, sum of is empty. What is empty? You are saying that, if you are summing over, um, oh, you're saying if the index, if a type index is empty, like if this sheet text no, okay, yeah, of course, that's not what I want. Close loop, but not quite. That's not what I want either. How do I mean, there has to be an easy way to do this. Just don't see it. Maybe this. Oh, maybe this. This is this. So s.to list a map. Okay. So how do you? Okay. Then what is to list of a Wait, what is this? How to sum a list? Okay, good. So okay. Then let's try this. So rewrite what inset sum map to list. Oh, this is actually giving me something meaningful. Okay, so you are mapping, this is not, okay, good to know. Then what? Then I will have to say this is, list the map. Why? List the map, this thing to list. Okay, so now the question is, what do I have instead to list, bigvec1 to list? Uh, what? Wait a moment. I feel like something is really funny here. So, when I say this, what does this give me? This is literally giving me a, oh, literally giving me all the possible values in there, isn't it? Then, bitvec1, what? How do I get a literal? I think it's this, right? What is this? This is Finset. Huh? Oh, because this is already a set, so this is not really doing much. I should say, okay, so maybe I should be finset.unif. What is this? Finset.unif is a it's a finite set. Okay, what I was writing down is maybe a bit useless. Um, how about this? If I do literally this, some this is this. No, that is not even correct. Of course, it's not. Hmm. There is certainly something simple and missing here. Like this thing has to be a what is it called? Oh, something like this, I guess. Um, yeah, something like this should allow me to pull out a single term. Um, range, not range, not count either. Something is really. Do I? No, that's not. It's really don't need any of this. Is this what I want? No. Feel like it's gotta be something very simple. Like, how long is this list? Is it long enough that mm, is this? No, that's not it. Um, is this what is it? Um, don't think so. Um, what is this? I mean, I'm pretty sure this is not what I want, but still, what is this? I don't know. Maybe I don't have to know. Okay, let's try direct unfolding again because there is a yeah. Okay, so what's the difference between okay? So this and this, but what we have is a second version. So finite set universe. Okay. So okay, so there is a filter thing I can do, but how do I okay? let's try to do if I can search for the right thing. So finset sum, finset filter. Does it give me a it does not let me filter out a single term. Which is suspicious because it really should allow me to um okay, so if I force this, then the thing is that this is multi-sum. So multi-set sum, okay, so that means I need to what's this? This is just finset sum, right? And then I rewrite multi. Well, what do I rewrite here? I rewrite finset unit file, I think. Cannot be rewritten. Why not? Um, this is a multi-set. Okay. So what if I do okay, I do have this, okay. Um, then what do I have next? Um, wow, wait, that's it? I mean, I shouldn't complain about that, but this is, can I do sufficient? Is there a, no. Well, that's anticlimactic. After working on this for, I don't know, after getting stuck for a bit longer than I should have, now we just have just this, right? So what is actually going on here? Well, I basically just, well, do I even need this? I do, yeah, okay. So basically we rewrite this and we just say that we have this very nice thing, but then this very nice thing is literally just this because um yeah. And then if I had that, I mean this by definition just like this. Then but why is this true by definition? What exactly is going on here? This is I mean I guess things are computable here maybe. Anyway, so if I had this, then wait, this is a multi-set, and so is this. So this is a multi-set. Oh yeah, whatever. And then well, this is literally by computation, I guess. And then now, if you had that, then you had this, and then if you had this, then apparently this allows you to. This is just compute. Okay, yeah, whatever. Maybe I should just be glad and nothing too much about why this works. There's too much of things that just work. Okay, so now 2 files down, a lot to go. Where are the other low-hanging fruits? Wait, there's nothing. Oh, no, we just did this one. So we did this and this. So we have 3 more to go. Unless there is, okay, so we have this, poly things. Oh, this is a bit scary. Okay then. Well, first of all, this does not like me, but that's fine. Okay. Is there any other, is this any easier? This might be easier. Pure state stuff. This is, what the heck is going on here? Why is this not free? This is, are these unitaries? Yeah, these are unitaries. So you're saying that, you're saying what? You're saying that this, wait, no, this is left and right hand side is DGSM. So I just, yeah, reflexively, so I don't care. I just delete this. I mean, if it's reflexive, I can delete it, but we can try to reflect it first to see what happens. It's just going to be reflexive, I'm sure. Problem is this. Um, things are going to be very, very normalized. Um, what you have, right? So this is literally just algebra, right? This is literally just saying, okay, if this, I mean, except this is a real known type of algebra because this is very high dimensional, so I cannot brute force this. Um, well, okay, so what's the norm of this? The norm of this is square this, square that, and then I have some cross terms. Cross terms goes to 0 because you have this orthogonal thing. So long story short, just do math, right? Well, first of all, yeah, whatever. I saw nothing. Okay, so anyways, what are the I mean, if this is a low hanging fruit, I just grab it, but I don't think this is. I mean, maybe far from it. Maybe this is going to be a trickiest part. Oh, did not mean to do that. I mean, there are some low hanging fruits, just and some not so low hanging fruits. Good, yeah. Are this easy? This might be the easy ones. Yeah, if these are the easy ones, let's just try them. Always, I mean, because right now we are really lacking in experience with this programming language, we start with the easy ones. Okay, so let me see. What's going on here? This is what is the P state? A P state is a sure. And what's a cat? A cat is a vector of norm. Very bundled. Okay, sure, whatever. Very nice bundling. Wait, I was not looking at this, was I? I was looking at this, yeah. Okay, so it turns out both of these are low-hanging fruits, and we can do both of these, and the other one we worry about after that. Okay, so now we want to say what? We want to say, well, we want to say that we rewrite qubit 0. The 0th qubit will give us What does it mean to apply a vector? I don't know. This is a... What on earth is this? Um... What's going on here? Please. This is... I'm actually losing my mind here. What is going on here? Okay, so you have a vector, yeah. You have a vector and then what? Fin n to a, okay, yeah. So you have fin n to a, and then what do you want here? You want to say fin n to a is you, but why? Oh, because you have this. You've got to be kidding. Okay, fine. So you have this very nice transportation. So this gets transported to the make no progress in. um, worth try. Um, Here we don't care about things being normalized. How do I drop a normalization requirement? We first say, okay, first of all, what the heck is going on here? There's some application. So what is vector.apply? Um, cat.mk. I don't think this is going to work, is it? Doesn't work the way I think. How do I? There has to be a way to destruct to do the destruct on this, because here you have here you have a bundle, and I don't really care about a second element of a bundle. So yeah, okay. What is this cat thing? Yeah, maybe that's a real question. What is this cat? Cat is okay. So now you have this bracket thing, which is funny, but whatever. And then you want to say apply cat.apply. Okay. So you want to rewrite cat.apply kt.apply. Okay. Do you have this? Okay, good to see this. And then what? And then I have do you not have okay, good. Where is this nonsense defined? I mean, this has to be defined somewhere. I hope. What on earth? Um, huh? Huh? I mean, I'm actually losing my mind here. What is going on? I feel like I should know. This also looks like assembly. This I know it's not assembly. Oh, what on earth? Huh? Um, well, I mean, that is not a bad way to do this, but well, first of all, okay, good to know that you have double, don't like it. Okay, oh, maybe you like it like this. Okay, good. If I literally just unfold this, what do I get? If I just unfold this, it seems to be making progress. I'm not sure. Vec. Okay, then what? This is literally just a what's this? This is just applying, right? So I should be able to get this thing to be to solve. I mean, this should I should be able to discharge this like a trivially. Vec empty vec cons. I mean, either way, this should be. Hmm. It'd be some kind of vec apply, right? Um, I'm not sure how much should I be afraid that the order is actually reversed, but maybe I'll just stay optimistic and hope this checks out. Um, cons val 0. Is there a way to 1 and then 2 is what? Is there 0? Does not apply. Why not? Um, did not. Why not? Did not. Okay, so vecons. What's vecons? This is you're kidding, right? Fine. Okay, let's trivial. Um, that also is doing nothing. That is good. Yeah, okay. So, good to know. Then what, right? Um, what does this do? Okay. So, first of all, I don't need this any. Well, fine, let's keep this for now. So you are saying you cannot find an occurrence of this pattern, but this pattern is, this is, oh, because this, you're kidding me, right? Do I have to say up 0, 0? Um, this is, this is actually just 0, but this is up, up net 0, okay, yeah, this is going to be very much a, what is this? This is, what's this 0? This 0 is, this is a natural, this is the, okay, and then this is the, netcast to fin2. This is, and then this 0 is fin2. But then you do have this, what is this? Net, wait, no. The entire left hand side is fin2, right? This is fin2, but then this is natural 0. So I want to say this natural 0, once you cast this natural 0, what is going on here? This is net, okay, net cast fin2 at net dot cast fin2. That is not it. Why is this not it? I mean that it's obviously why this is not possible. Um, okay, so let's see. Can I say this? What are you talking about? This is actually I'm not happy about this. I mean, it's obviously why I'm not happy about this, but I'm not happy about this. Like, what is this? There's no, is there a way to just, if I did this, it's not, yeah. What on earth is this? What is this thing doing here? This is, so you're saying that this is fin2 and this is, what if, okay, hear me out. Why do you not like me? Okay. Then if that is the case, then how about this? Still no? Type U and R. So this is saying that it takes a, which one is which? Which parameter is which? We have one. Is this three, right? Or is it this? I mean, no, it has to be this. This has to be mapped to how many parameters? No, this has to be the internet casting. So which one is this? Is fin2? This is fin. One of either U or R is fin2. I mean, what if R is fin2? If R is fin2, then you need a netcast fin2. And then now this, yeah, and then of course, yeah, so R is fin2. So, R is fin2, this is N, this is net. So if I had this, then, just make sure this doesn't break anything before I go further. Okay, this is why this. So what if I do, this is a natural number now. Why do you not like me? Well, okay, so why do you not type check? Because you don't have a netcast. Really? You copy kidding? I mean, okay, fine. What is this? Do you really not have? Still no? No? How much do I care about this? You don't infer. You have no instance. Okay, now if I did not have this, this is not going to work, yeah. So I still need to do a cast here, but then after that this works. I mean, can I just no, like there has to be a there has to be some way to, well, okay, first of all, if I don't have this, then what happens? Then right, then it doesn't even, okay, yeah, whatever. Okay, well, let's clean this up a little bit first because otherwise we are going to reuse the same thing like 5 times. Okay, so you have what? If I do this, it's not going to break anything, right? Okay, so I do this and that and that. Okay, this gives me this, and then I want to say oh, bad. And then what? Why is it breaking? Because this is really broken. So after this, I get this, and then I need to simplify again. But then if I just did this, would it be fine? Yeah, it would. Good, close enough. So now what? Now, now, wait. This is not giving me much. Oh, because of course. Okay. Wait. Actually, in fact, the entire proof just goes right. I just say instead of this is const val. Okay, then. So I have this, and then once I hit this with EQ fin, I have. Wait, this is just done. That's funny. So why is it that once I hit with that, it's not done? Whatever. This is qubit 1 now. And then I hit it with this, and this is the entire thing is just happy. That is crazy. Not complaining though. Okay, I have proven some stuff that I don't know, that I don't believe in, but that is fine. Um, Now time to do some linear algebra, I suppose. Um, yeah, very good. I mean, we've been doing linear algebra, we can do more linear algebra. So, this is what? This is how terrible is this? What's this nonsense? Well, this is a very nice code to say it. I don't know. Okay, so this is what is this trying to say here? This is saying that okay, cat zero is yeah. Well, what is this trying to do here? Mm, well, first of all, what is this? This is pure state, and if it's a pure state, then what do you have of a pure state? Then you have a cat. Cat is you need vector and a proof that is normalized. So is that what's going on? I lost my place just now. Yeah, okay. Wait, is this where I was? Yeah, I think it was. So here you are saying that it's going here. Okay, so you're saying of course, yeah, sure. So you have I need to prove these are equal. This is what cat, right? Or p state. If you want to prove two p states are equal, you need to do this well, then you need to prove two cats are equal, and to prove two cats are equal, you need to it suffices to prove the underlying states are equal. So maybe that is what we can do. Okay. Okay, I will have to say what? I have to say the how do I do this destruct again? I forgot. Um, Maybe just this. It's not doing much. Um, oh, this is not math comp. Okay, then. Um, this does not new unfold left hand side. Um, okay, let's try this. Can I do sufficient? Cannot, because this funny. I am full reasoning this. Wait, how do I even do full reasoning here? This is actually funny. Um. Uh. Um. Doesn't do anything. I mean, this I know is true because this is literally just a Oh, maybe I unfold structure. But no, I mean, there's nothing to unfold here. So I kept looking my place because this is. Hmm. Yeah, this is a. How about this? This is Okay, so. Um. Yeah. Well, I mean, well, that is thinking. Just try the most obvious thing. Huh? But then this is actually there has to be some what's it called? Piece data apply. No, this is applying a unitary. That's not what I want. Um, maybe the funny question is how do you Well, I mean, okay, so there's definitely cat apply, right? Cat dot apply, okay. Cat dot apply, cat dot apply. Maybe the other way? No, it's this, okay. Um, okay, sure, yeah. Whatever, okay. So you have this, and then now you have, you know, so that makes things a bit easier, question mark. Now what? Now I need to say, now I need to do extensionality, right? So, can say that this is, use a fact that it is linear. And once this is linear, I can, okay, yeah, maybe. That's not what I want to do here. Oh, because I want to say case fin one is the something like this, something like the something that give me R cases to work with. By saying that okay, if this is true for true for if I want to prove this true for this, now I want to just prove it true for both zeros and ones, both possible values of this. I think I actually proven this earlier, right? Or they only prove it in the weaker thing, not here. I thought I proven something like that earlier. Maybe a weaker version of it. Yeah, something weaker. So here I want to say what? That is not what I want to do. Let me see then. Well, first of all, what's going on here? If this were back this is pure state. This is just a number. So here is wait, what? This is so vec of 0 is should be vec of 0, and then this should be yeah, so this is the correct factor, and I will have to say that the 0 goes here and give me a this applies to this, gives me a number 1. To show everything is linear. Why do I still have piece? No, that's fine, yeah. Please, because when once you do vec, this is literally just actually I don't care about this being a cat ear, right? So I could do another level of unfolding slash destructing if I want, because this is normalized and I don't really care about normalization, but I also don't care about this. Don't care about doing another layer of destroy. Let's be much. Okay, sure, whatever. So okay, good. So what is this is that my colleague said, colleague slash teammate. Okay, somewhere here. Mm, yeah, there's this cases thing. Ah, yes, okay. So this would be okay, so I think that is the right pattern. Basically, I will have to say well, I copy this and I see if I can make something similar here. I will have to say lemma what fin 0, no, fin 1 cases. Um Wait, huh? No, I copy wrong thing. I will have to say that if a I is in the nothing one, the bitvec 1 cases. If this is bitvec 1, then that means I is in or oh, that's funny. No, I want this. I is okay, because there is, yeah, actually maybe there is a there has to be some ways to deal with this. Um, maybe I can brute force this. Um, no. There has to be some easy way to do this. In fact, maybe I could just shove this to the AI. AI can probably do it for me. Well, not ChatGPT, but maybe ChatGPT is fine too. I mean, it's probably not going to give me a correct proof, but why not, right? I mean, if you actually give me something correct, then I'll be very happy. But yeah, maybe I should make tea. Well, yeah, let me make tea. I'll be right back. Actually, instead of tea, I'm really tempted to get another gin tonic. Maybe I just should. What is this? Cannot be. I mean, okay, sure. I mean, chances are this is not going to work, but doesn't hurt to to give it a try. Wait, this is actually surprisingly okay, so what do you have here? You have um this is not even okay, sure, whatever. Um eh? Have this using that, okay. And then I mean if interval cases does not work, like if we don't like it, then we can say this instead, okay? Maybe this is going to work. Is this what I think it is? Um, surprisingly close. And then, but yeah, okay. If I do this, then what happens? Then this actually works. Wow, okay. Okay then. So what do we have here? It's going to step away to get some gin tonic, but now maybe this is worth doing. Before I get up. Um. Of course not, right? Okay, so if x is less than 2, then, I mean, this sounds obvious, but how do I, you know, if this less than 2, then, mm, wait, huh? So this is, you're actually doing, wait, I feel like it's just wasting time doing, let me see, yeah, whatever, wait, what's going on here? You have this, and then you want to, what do you want to prove? Okay, and then you want to say you have this, but then you already have that, so why do you want a second one? You don't care about having a second one of this. This is exactly the same thing. And then you have, what? You have, okay, now the fun part. Um, First of all, what the heck is going on here? Okay, yeah, whatever, that's right. Or how does this other interval cases work? Don't know. Maybe I don't want to know, or maybe I do want to know. I just don't know. Um, some inequality nonsense that is worth doing. And I can say that for some contradiction, let's say if x were not 0 and not 1, then what, right? Then if x were not 0 or not 1, then x is some other number, and that other number will have to be greater than 2, but that is there's some total order thing that is a that is being brushed under a rug that I really don't know how to don't actually need this. as unused. This is actually okay, I have this, and then this is giving me that. Um, sure, whatever. And then now this is why does this? Yeah, of course. So the really funny thing is actually just the inequality part. Good, yeah. So just let me keep real quick while thinking a bit about this inequality, or also wondering how much should I actually dig into this inequality, because I feel like there's well, I don't know. Mm, there's some natural number thing that can be done. Let's try to quickly see, I guess, even just for the sake of understanding how to work with natural numbers in then. Okay, so what do we have? This is this, and then, okay. I mean, oh, order maybe. But this is not. Okay, let me actually just. Yeah, I think this is definitely something that I can throw at the AI. I'm probably going to do that in a bit. But for now, let's say I have this, then how do I do R cases here? R cases. You know, I pulled an example just now and I forgot where is it. Um, right, where is it? Not that. Okay, so I have this and then R cases. Okay, yeah, so R cases, what feedback one cases I, okay, unknown tactic. What do we by unknown tactic? Oh, unsolved goals. Yeah, there's a lot of unsolved goals. Let me see. What do we have? Um, huh? Wait, what? There has to be, yeah, there's more than one, yeah. But if I did this, then, Oh, right, okay, now this is actually how it is. Okay, so if this were one, then what happens? This were let me see. Simplify first. Simplify to nothing, I think. I think. What is why is complaining? It's just no progress. Oh, because yeah, you keep this. Okay. Then what? Then I have what's going on here? Oh, this is some kind of funny. Oh, with edge. Yeah, why not? Why it is not like me? Because no goals will be solved. What do you mean? Oh, okay. Now this is actually more reasonable. Okay, good. In that case, I want to rewrite h0 everywhere. Or can I just do a substitution? I can, right? Um, this is really stupid, but okay, yeah, this will have to do for. Oh, can I just do this in rewrite everywhere? I guess it does. It was not doing this earlier. Oh well, whatever. Okay, so now with that said, what do we do here? Um, Qubit 0, yeah, I think we just had proven that thing earlier, right? So I just have to say cube 0, 0, cube 0, okay, yeah. Actually, can I just do simplify? Maybe this solves it, no, okay. Cube 0, 0? No, why not? Because I make it a oh, I should not have done this thing then. Okay, so if I did not do this, then what do I have, right? Then I had this. Fine. If I don't do this either, then what? Then I have this is my state, which looks absolutely terrible. And then I do this, and I do. No, I will have to do this. Yeah. I mean, this is really stupid. Okay, so how do I make use of that darn thing above? How much do I care to make use of that? I mean, okay, fine. So, back apply, right? Um, Um, if I'm actually losing my mind here, but whatever. Okay. Then this is cube 01, right? Also, this is named really badly, isn't it? Because this is, oh no, this is fine. Yeah, okay. Good. Yeah. So now I do this, and then I do cube. Feel like this is kind of I mean, I know this is not the intention of my colleague, but this is really but I feel my sanity points dropping because this is just not the way to do things. But I guess that is also how it is, right? We never knew what is the right way to do things until we start doing it, and then we realize that things are not right. Sure, whatever. And then what? This is a also this is what there is something else I had to rewrite. So oh yeah, Cupid one vex 0. And then I can just do a simplify here. If it discharge the entire thing, it does. Okay, good. Okay, so h1 and then simplify what? Cube 0 vex 0 and then nothing. Cube 0 vex 1 maybe. Cube 1 vex 1. And that discharges it. Okay, good. Perfect. Um, Perfect up to this complete nonsense here. Let me see if I can quickly throw this to the yeah, let me try to I'm going to do this for a bit so I don't accidentally show my API key, but I will just throw this thing at the AI and see what the AI says because this is a because I mean I do have a hole earlier and I want to fill it. So yeah. So what is this? This is a oh, I think I can still share this part. Perfect. So I want to say I want to say what? I want to say that oh, you cannot do that because of course you cannot. Okay, so you have this and then you just paste this over and say you don't have a proof because the AI is about to solve it for you. And then I will have to, well, I mean, I guess the thing is I can just bring in everything that has to do with BitVex. So, which would be, yeah, mathlib. Oh, I don't want to delete that. Um, don't need any of this, but just import mathlib, data BitVex. Okay. And then okay, now is maybe the part where I actually don't want to show my API key. I forgot if API key is hard coded in there. I think it is, so I have to do this and then yeah, the API key is hard coded. Good that I stopped sharing my screen. Here's basic.len, and then here we just want to run this thing. How do I run this? Okay, so oh, okay, good. Yeah, I'm not showing my screen. Chances are this is fine, whatever. Okay, good. Now back to the interesting part. Which is okay. Yeah, good. Now let's pretend that this thing is actually just solved because there's no a because I don't know how to do it. Okay. So now let's actually do a bit of linear algebra. So what do we have here? Well, new restart file. New check that okay, I'm still not taking my API key. That's good. The thing is going to take forever because that's how AIs always are. I just hope the thing actually gives me a sensible answer at the end because if not, that is life. Okay. So what do I do here? I just have to why is this orthogonal thing defined? Orthogonal is this you just defined based on the underlying vector, right? Okay, good to know. So what this is wait, you're kidding. You're kidding. You are kidding. What is going on here? There has to be a better way to there's no built-in way to do this, is there? Bet there's a built-in way to do this, and I bet none of this is necessary. Whatever. At this point, I don't care enough. Okay, let's just do some linear algebra because why not? So what do we have? We want to show that dot product between this and that is zero. So I want to say that this thing should be easy. In fact I don't even need both of the hypotheses. You just have to say that this thing actually respects dot product. Except this thing is literally a I mean this is just this which let me see. Right, why does this respect dot product? Okay, just make sure that you are actually hearing me. Um, dot cat product. So what I'm about to do might not be overkill, but okay. So let's see what's going on here. So oh yeah, this is overkill, isn't it? So what's the dot product? So we have connector nonsense. I feel like I kind of don't want to grab my drawing tablet for this because this is a something that shouldn't be hard. But I mean, it's alright. Oh, I mean no, like Kronecker is a Kronecker has to give me something. If we weren't using this garbage notion of Kronecker, it would have given us something. Okay, good. So what is going on here? Um, of course not. Yeah, I mean this makes no sense to begin with. Actually, I think it might make some sense. Just oh, I'm not sure if I like it actually. What is this? Yeah, I'm not fully sure if I like this. I mean, there's a lot of things I don't like, and I feel like this might be one of them. But anyways, let's actually see if you for real. I mean, why not, right? Sure. Okay, good. One last thing on my mind. Don't know why, don't know how this works. So you want to say let this, and then what is this? So this is just brute force. So it's saying that okay, you have what? Just for the sake of understanding this, take this apart a little bit. What's going on here? Okay, so what do we have here? After this, it is giving me case 0, which is oh, huh? Oh, this is proof of induction. And then once you have this, you literally just hit it with, because of course you can, yeah. Because this is a well, good. Now what? Now good. Now back to linear algebra, question mark. Or first fill in some easier ones, I guess. I feel like this is a point where I'm not fully sure if I can finish all of it today. Um, why does this look familiar? Am I just proving different versions of the same thing? Or am I just doing linear algebra over and over again? I mean, both, right? Sure, whatever. Okay, so I have this, that, and then what do we have here? We have some Pauli nonsense that might be not hard to show. This is Hermitian. Okay, what do we have here? Maybe you might as well, if this is trivial, then we can do it right now. If not, then it's whatever. Um, okay, yeah, just simplify everything. But then that is no, you want to do our cases, and then this is just doesn't work. Okay. So you want to say that, okay, so why does this not work, right? Oh, okay. Okay, so you want to say that you have this is a you show that this thing is Hermitian. So what is this? This is just poly X. Poly X is Hermitian because you can it's just literally just by brute force, right? Do not work. Okay, that is fine, yeah. Do you work? Doesn't work the way I think. Okay, good, yeah. So what do you want to say? You want to rewrite, is her mission, and then you want to, am I not spelling right? Unless this is, I mean, chances are this might just be a, this thing is actually not, what? But then it has to be somewhere, right? Or matrix dot, yeah. Maybe you have to do this. And then, yeah, this is, and then this literally just a, and then you do what? This is true for all. This is just, there's a lot of brute forcing to do here. Um, Too much brute forcing, in fact. Mm, mm, yeah. Um, need this. Why do I need that one? Like, what is this? Because this is unitary and you want to... What is unitary? Unitary is saying that you... Because you have this huge proof saying that it's unitary, whatever, sure. Okay, what? So you, rewrite... Or simplify. Um... Write a px, and then, simplify. Simplify gives no progress because you cannot, because print you cannot simplify away this thing. That is funny. How about this? Can you simplify now? You still cannot simplify. What is going on here? This is... Oh, this is literally just... Can I just do just X? Maybe I can. But then what the heck is going on here? Oh, because of course, This is just reindex, right? I mean, this has to be just reindex. Unitary finiquiff. What is unitary finiquiff? Yeah, let's just reindex. Okay, so Hermitian reindex. What is this? Yeah, what is this? You do this outside because it's just crazy. Okay, so fine. What is reindex? Reindex Hermitian. There has to be a this is no? Why not? Or is Hermitian rare? Unless reindexing make you not Hermitian, which would be the case, wouldn't it? Of course it would be. Of course, reindexing will make you not Hermitian because you can do this very nice thing. Um, because reindexing is not actually reindexing. Okay, good, yeah. So what? Mm, I mean, at this point, this is brute forceable. We can just brute force this. Maybe this is one of those things that is worth brute forcing. So, we want to say what? We want to say, yeah, I don't even need this, right? And I just do a, and then what? And then I do this, a, okay, so this conjugate transpose can probably be, um, you know, this and the application can definitely be, what is this single thing? Oh no, I don't care about this. Um, conjugate transpose, and then, oh, there we go. Yeah, conjugate transpose apply. Okay. So, and then I would do, or just ij is fine. And then I do, what? I do, conjugate transpose apply. Okay, then, well, then I just case ij, right? This is going to be a in the tailbone, but um, I know somewhere I was able to. I mean, just now, right? Just now I was able to case the I was able to case the freaking. Oh, I shouldn't curse. Sorry. I was able to case a very nice this very nice what is it called bitback one, right? So I just take this and then do this crazy thing where I move this over here and then I hope everything still compiles because you know, and with that done I should be able to case this very nice thing as well. So I want to do Okay. And then can I just do this? Oh, maybe I cannot. No, no, this is just crazy. There has to be a better this is, I mean, I don't think this is going to go, but you know, if it does, then it does, right? And then what? And then this is just a yeah. I mean, this is not going to work. I already know, but yeah. Why is this not trivial? I mean, this looks trivial to me. I mean, a lot of this look trivial to me, but it's probably actually not trivial. I mean, also this just looks terrible, but that is yeah. I guess there's this Ocos simplified thing which I could try, but yeah. I mean, this entire situation just leaves so much to be desired. But yeah. Well, at least there's nothing left in here. And for this, okay. So how do I? I feel like so much of this can be done with AI. It's just that by doing this with AI, it just spits out terrible looking proof. I'm tempted to, well, things I have to wake up in like 8 hours, so I should call it soonish. Um, Even though I kind of want to be more gin tonic and keep going here. But I feel like that is not meant to be a spaceship because this is, of course. Uh, okay, yeah, I mean, at some point I will still have to unfold this poly X, right? At least all the way down to the yeah. What if I what unitary thing there's a lot of unfolding I can do here, but I'm not sure if any of this is good. Um, this is a bit better, I think. Um, except now this breaks, right? Because why does it break? Because once you do this, you don't, okay, yeah, so I have to move this here, and then I can, oh, if I did this here, then what, right? If I did this here, simplify makes no progress, because I need to, there's no, I mean, this does nothing, right? It does something? Okay, I think that is close the deepest this goes. So now what? Now what? Now this is saying that well, I mean, rewrite h0 and h0 prime, right? Uh, and then maybe simplify as well while we're at it. And then what? And then you. And then this would be a way to do this. Well, I mean, I guess this is where the earlier thing comes to play, where we just say, is this still a matrix? Yeah, it is. If it is still a matrix, then I should be able to yeah, if this were still a matrix, then I should be able to do the matrix stuff. Um, where would that be? Yeah, let's trying to dig up an earlier version because it has to be somewhere. Which would be like what, unitary Pauli? Mm, I mean, this is of course not. Yeah. Well, I mean, this can certainly be unfolded. It's just don't know how, because this is a I mean, this is obvious. This thing over here is obviously one. So okay, and then of course you don't like me because you never do. Expected type is not found because I want to say this entire thing is a this is a fin2, yeah. So this is so then what would this be? Still no? How about this? This is not how it goes, is it? Ah, What is this then? Um, no, like this is just way too ugly. I don't think I want to copy this into I mean, this would do it, but I just don't want to, copy and paste this directly here. That is too much. That's way too much. Um, there has to be a better way. Well, I mean, like this has to give me some there has to be a way to okay, just for another sanity check, I guess. What star ring and C of one is one. Uh, doesn't do it. Rewrite star ring and simplify. Okay, yeah. So this can be done easily. So basically, okay. So now I just have to prove that this were one, and then we would be good. So how do I prove that this were one? Um, well, I mean, I just unfolded the way I did, right? It's, at least I can simplify, which makes things slightly better looking. And then I will say that this is, oh, okay. So I just have to do the same thing as before. Basically, I just have to say this is this up zero is just zero. And how did I do it earlier? Um, Earlier I was grabbing some instance from somewhere, right? I remember doing this like 10 minutes ago. Assuming this is actually the same thing, is it? Here I'm casting, yeah, this is natural number to, yeah, that's the same thing. That's good. So, why, but why do we have natural number? This case zero is, this should not be a natural number. So I feel like there's some funny things going on that give me natural numbers, even if I don't mean to have natural numbers. And that is bothering me just a little bit. But I mean, maybe there is a more to. I mean, I guess if I were to be bothered, there's like a million things I could be bothered by. So this is a So I feel like maybe I should be past that point. Okay. So so with this netcast, I should have this, right? And then I would just rewrite this for however many times, and then I should be able to rewrite a matrix const file 0 do this twice. Simplify star ring int. Okay, then just to simplify this, do I need to do this twice or can I just do it once? Okay, yeah, so this is literally just simplified hint. It just hit it for however many times it can. It's good to know. h0 h1 prime, and then I should be moving this out, right? So I could attempt to do, wait, oh, I cannot, I don't want to. Not because I'm lazy, but I don't want to because that is just terrifying looking if I tried. Um, this, yeah, that's acceptable. And then I have to say that this is 0 and then rewrite this, but then I also need to rewrite the other thing, right? Oh, okay then. Um, Not complain too much about why this works. Um, why am I simplifying? Well, I should know this. I'm simplifying h1 and h0 prime. So this is this, and then this is yeah, okay, that makes a lot of sense, yeah. Do I need this? I think I do, yeah. Simplify that, yeah, okay. So this is basically the same thing here, except now this is one, and then and I don't even need this or that. None of this. Okay, and this is giving me something sensible, except this is terrible. Uh, yeah, I mean, there's at least, I mean, all of this is a lost cause, but what on earth? Why? Why? Okay, you could do that, but the moment I did, wait, so this works and that works, but if I did just this and it stopped working because of course it would stop working. You know what? Maybe I don't know. Maybe I don't care why. I mean, if I did, there's literally no end to this. It's just yeah. I mean, this case this makes sense. So I mean, I'm getting this is to wait to thin because this is equal fin. Wait, but why? Why? Finite. Um. Okay, we hate it. We hate it very much. Um. Yeah, we hate this a lot. I think I should just sleep because like this is a I mean the thing is I'm not even sure if I should be spending this amount of sanity points on this because this is not even my own project. But whatever. Wait, what? So you are case poly with this, then of course you are going to have that, yeah. And you rewrite poly here, so you have okay, yeah, and then you if it's in there, then it is, wait, this is a what? This is a fin set, okay. And then you can arcase a fin set that is good, yeah, okay. Um, yeah, I feel like maybe we should attempt to continue tomorrow. I mean, ideally we should continue tomorrow because I would like to do more of this, both because it's productive and this is I mean, to be honest, like, I probably should be streaming Silk Song or something instead of this, but oh well. Either way, I should just is this low hanging fruit? If it is, I can deal with this as well before I go sleep. But what's this? This is identity matrix being identity matrix being in poly group. Is it not? Isn't it trivial? Oh, what's going on here? That's terrifying, actually. Um, sure, whatever. Just showing some proofs, I guess. This is fine, and then this is, well, yeah, I'm just quickly seeing what is there. Okay, this is meaningful, and so is this. Yeah, is there a way for me to quickly do this? There's not, that is hard. And this is, well, this is why it is. Yeah, okay, fill in some proofs. Now I need to, well, this should be on a different branch, but I could commit first and then do some git things, I think. Okay, so I would do, if I can call up my terminal, why can I not call up my terminal? Maybe I need to, oh, not need to reload window here. Need to turn off win mode, but whatever. At least I did not hit the button, magic button that rebuilds my entire, what is it called? Rebuilds the, Docker container, which would be tragic because it would take forever to build. This thing is not containerized. Why do I have like 4 of these? Okay. I don't. I do have VM. Sure, whatever. It doesn't matter. Okay. And then what do I want to do? Hmm. Do I want to say what proofs? I probably do, right? So this is what proof summary. Proof some. Prove something out rough X, I guess. Yeah, maybe verify some linear algebra background. Yeah, that would do. Okay, some linear algebra backgrounds. Close enough. Okay, so now I want to do git branch. I want to check out more proofs, I guess, filling proofs. I don't know. Something like that, I guess. I don't know. Oh, wow. No, this is not pre-recorded. No. Shoot. I did not. I did not notice this. How long ago was this? Sorry. Um. shoot, my bad. How do I check when was this? I hope I did not. I mean, I probably missed this. Sorry about that. No, this is not pre-recorded. Where was I? Yeah, check about. Yeah, okay. Anyways, where was I? No, I was. This is just not watching chat, but no, this is not pre-recorded. um, where was I? Um, yeah, sorry about that. I don't know what to. Probably should have said earlier. Um, yeah. How do I? Is there timestamp? There is. I don't know. Either way, back to this for a moment. What do I want to do here? Commit message. No, branch name. Proofs. I don't know. Mm, okay, yeah, close enough. Let me see. And then I want to say that I want to reset this, right? Like this, I guess. Yeah, okay, good. And then I want to throw a pull request. Let me see. Need to monitor the chat a bit more carefully next time so I don't miss messages. Let me see. Yeah. Does it make sense? A lot of this makes sense, I guess. Well, yeah, why not? And then we can always do this other thing. Yeah, so anyways, where was I? Guess I should just call it a day anyways. And also things where I was in the future watching about, I guess. Let me see. Yep. Yeah, wake up in like 8-ish hours. I should do more tomorrow, silk song or whatever, and hopefully not make a same mistake again for missing a comment. And yeah, I will see you. Thank you for meeting. Good night.